Hi YouTube, this is Antonio. So today we are going to talk about the triple science knowledge for chemistry, and we are focusing on the polymers in this session. Alright, now for a lot of students, okay, they find this a bit more difficult because it's quite hard to visualize. But let's start with some double science knowledge, alright, which is the addition polymers. Now for addition polymers, they all have something in common, which is that they have a carbon-carbon double bond, which means that they are unsaturated. Now, this is a molecule of polyethylene, alright, polyethylene right there, okay. So basically, initially there was a carbon-carbon double bond right here. To show the formula of a polymer, all you have to do, you draw a bond right there, a bond right here, okay, put it in brackets, and put an N on the bottom right, okay. With this, you will have addition polymers, easy. Now, if you're doing polypropylene, just replace one of the H's with CH3, and then that's going to be one. And if you replace the H with a Cl, that's another one. Okay, moving on. So, you have to understand that some polymers, such as nylon, would be formed by a different process, and we call that a condensation polymerization. Now, in condensation reactions, it will form a bond, it will form a covalent bond, but would give up or give off a small molecule. And in most cases, or the examples you need for IGCSEs, this is water. So right over here, follow my cursor, this is the carboxylic acid or dicarboxylic acid, okay, COOH, OH group right here. And then over here, you have an amine group, okay. Now, if the OH here and the H here comes together and forms a water molecule, okay, the release of this water molecule and the formation of the covalent bond right here, you can see here, okay, this is a condensation reaction, okay, and you can have a repeating unit, okay, put it in brackets and put an N on the bottom right, and as it continues, it will keep on producing water molecules, alright. Looking down, we can also do it with a carboxylic acid and also an alcohol functional group, okay. So again, the H here, okay, and the OH here, bam, they come off as water, and then the O will link up with this carbon over here, and we call this a polyester. Alright, now the one on top here is the polyamide, and this is a polyester, so do recognize the difference. Now, moving on, the raw materials required to make sulfuric acid is sulfur, air, and water, and you have to know about the contact process. Now, the essential conditions are as follows: a temperature of around 450 degrees, 2 atm pressure, and vanadium V oxide. Now, the general flow in making sulfuric acid is that you have to combust sulfur in air, and that forms SO2. You can further burn SO2, it forms sulfur trioxide, SO3. And then you react with something called the oleum, alright, to form, okay, it reacted with sulfuric acid to form the oleum, and then you can further dilute this oleum to form more sulfuric acid, alright, so you use sulfuric acid to make more sulfuric acid, okay, so basically, you have to know that the use of sulfuric acid is that they can be used for detergents, fertilizers, and paints. Okay, now, we also want to make sodium hydroxide, and sometimes we also want to make chlorine. So what do? Okay, we do electrolysis of brine. Now, brine, all brine is that concentrated solution of sodium chloride, okay, in a diaphragm cell. So, let's look at the diagram right here. You put in concentrated sodium chloride solution, alright. You have two electrodes, okay, one positive, one negative, okay, and you see here, chlorine gas would be released, and hydrogen gas would be released right here. So, the diaphragm prevents the stuff from mixing together, let's say the gases from mixing together, and then you will have sodium hydroxide tapped off from the side. Alright, so this is the diagram that you have to know, and you also need to know the associated ionic half equations when you have aqueous sodium chloride Okay, and this is actually what we learned in the first video. Okay, and for the important uses of sodium hydroxide, include the manufacture of bleach, paper, and soap. And for chlorine, you can sterilize water supplies, let's say in swimming pool. Okay, you can make bleach and also make hydrochloric acid. Alright, so thank you for watching. I hope you guys do really well. Please subscribe. I will make more videos for education, IB, A levels, anything awesome. Alright, so stay tuned. Okay, and comment and like the video if you like it. Okay, bye YouTube.